1.1.3 is an inequality. So let's copy down the question first. We have x squared plus 5x is smaller or equal to minus 4. Now an inequality is different from an equation. With an inequality you have a broad range of answers, whereas an equation you only have one or two definite answers that fit the equation. So in this case, what we want to do is want to get our problem in the standard trinomial form, which means you want ax squared plus bx plus c all on one side. So we move the negative 4 to the other side, giving us x squared plus 5x plus 4 is smaller or equal to 0. Then we're gonna solve it just like we would a normal equation, but then only one difference is gonna arise. That is the difference of our answer is not gonna be x is equal to, but rather we are going to identify our critical values that allow us to define where our answer is gonna lie. So doing the normal procedure, we open up two brackets, we'll place x in both of them, keep the sign as it is, and then we look for the factors of 4, here 4 and 1 and 2 and 2. Which one is likely to give us 5? Definitely not this pair, but 4 and 1, and it's positive 5. So it will be plus 4 and plus 1, where 4 plus 1 gives us 5 and 4 times 1 gives us 4. Then from here we don't write x is equal to, but rather we identify our critical values. In this case, if I say x plus 4 is equal to 0, then my critical value will be negative 4. Just like my answer would have been x is equal to negative 4 if it were an equation. Then the other critical value is negative 1. So we put negative 1 there. So once you have identified your critical values, you draw a straight line. Write down the smaller number first, minus 4, and then the bigger number, in this case minus 1. Then above this horizontal line lies the region greater than 0. Below this line lies the region smaller than 0. And then on this line we have equal to 0. It is sometimes beneficial for you to draw kind of like a y-axis, although it doesn't really help you much with the question itself, but it's always good as in it helps you identify which regions are what. So we know this is the positive y region, this is the negative y region, and this line is the line y is equal to 0. So after identifying our critical values, we now draw a parabola only concerned about the intercepts. So we draw something like this. And then we come back to this condition over here to try and help us identify which region do we shade. Where does our answer lie? Our answer is found when y is less than or equal to 0. So when is y less than or equal to 0? That is this region here. So we shade that answer or shade that region, and then we can define it for our answer. And remember, it includes minus 4 and minus 1 because of that or equal to that's there. So when we write down our final answer, we say, in order to define a bounded region in maths, we use these two symbols. And if it's bounded and inclusive, we also put the or equal to. So we write down our smaller number, and then we write down our bigger number over here. So when you read this answer, it states x has to be greater or equal to minus 4, but x has to be smaller or equal to minus 1. This is one way of representing the answer. The other way is you can say x is an element of all the numbers between minus 4 and minus 1. These square brackets show that -4 and -1 are included, so this is including the boundaries. We only put them under the condition that there is a or equal to here, of which there is in our question that we're dealing with. So that is your answer.